Welcome to EPG Pachala. This is philosophy. I am Dr. Venusa Tini from the Department of Philosophy, University of Hyderabad. The name of the module is Logical Empiricism and Philosophy of Science. The module is written by Dr. Kaushik Bhattacharya. Here basically we want to look at the development of philosophy of science, which has its origin in a movement called logical positivism or sometimes logical empiricism. And we can identify two groups of people who are actively involved in this movement. One is called Vienna Circle and the other is Reichenbach's Berlin School. These are a group of mathematicians, philosophers and scientists who are interested to bring about demarcation between what is science proper and what is not, like what is a pseudoscience. For this they have taken an approach called analytic approach in some sense, because or put it differently, linguistic approach. They want to consider the sentences of a scientific proposition, scientific language, and see whether a certain expression in science is meaningful or not. For example, by introducing this criteria, they want to eliminate metaphysical statements, and by saying that a scientific statement should be correlated with experience or observable facts, they are bringing this classification. They have introduced a rigorous method to bring this demarcation, and which is what we are interested to look at. What is this rigorous method? A method called verification. That is, how to verify that a sentence which is made in a scientific language is meaningful or not. Traditionally, we have seen that philosophy and science have a close relation. They grew together. Both of them are trying to understand what the world is like and what are the building blocks of this world. And so they were trying to explain the world of observation, the observable world, in terms of certain concepts or in terms of certain unobservable entities. They are trying to understand the nature of those unobservable entities. Let us take, for example, light. What is the ultimate nature of light? Is it a particle or is it wave? And they were trying to understand this theory of light. Suppose if it is a wave, that the theory of light is construed around wave, then we can explain certain feature of light, that it is that interference is possible, that there is a refraction and reflection and even polarization. All these concepts, all these things can be explained in terms of a wave theory of light. But if we try to explain certain phenomena of light, how a light can knock out certain electrons from a solid or liquid body, then this theory of light as a wave cannot explain or cannot give an account of this phenomena of light. So then we have to go for a theory of light as a particle. And then how do we resolve such an equation? So what actually is the ultimate nature of light? Is it particle or is it wave? And there are certain electromagnetic theory of wave which seems to be consistent with a wave theory of light, but then it fails to explain again a certain aspect of a theory of or the nature of light. So here is a problem that we have to understand. How are we to understand this nature of light? These are some of the questions which we have to take it beyond science proper, and then we are trying to explain this very nature of light in terms of entities which we don't have direct access. That means whether it's wave or particle, we don't have. Now of course we do have a better understanding of theory of light, that it is at sometimes particle, and sometimes it behaves like a wave. So we have found a way to reconcile these inconsistencies by taking both. That is just an example. Let us take another case where you see a very close relation between the science and philosophy. Again, science is interested in particular aspect of the world or reality. As we know that zoology is interested in the study of animals, and botany that of plants, and things like that. But we have to understand the world in a very general way also sometimes. For example, when we describe a certain fact, like a table is brown, or that a chalk or a book is on the table, we have to apply certain categories. So certain categories like particulars, that if something is an individual, it must be a particular. And if we're trying to explain the relation between a book which is on the table, a relation of book on the table, that is another thing. And we have to experience certain things in space-time. So space-time itself becomes a category. So we have to understand the structure of the world using certain categories: particulars, universals, relation in terms of space, times, and so we are using these categories, which are actually not given to us in experience, but we use these categories to explain the structure of the world, to explain our experience. So here is where it's very difficult to really bring a very strong distinction between science and philosophy. But unless we are able to bring this kind of rigorous distinction between science and philosophy, the progress of science is going to be hampered some way or the other, because more and more we will introduce concepts which which in principle cannot be given a reference, or that means terms which cannot be given an observable reference, or certain statements which cannot be verifiable in this factual world. And that way it is really going to affect the progress of science. So there has been an attempt by logical empiricism to delineate scientific practice from non-scientific practice. Let me just highlight another example. When we ask questions about, let us say, God, it seems we are trying to make a certain truth claim or cognitive claim about God when we say God is omnipotent, as if there is some kind of a being or an entity called God, and that God has certain predicates. And so when we make claims in the form of a proposition about this nature of God, it appears to be factual or cognitive. But the question remains, can we verify this claim? No, it has no cognitive content. In other words, sentences claiming about the nature of God in principle cannot satisfy verifiability criteria. In fact, these sentences are even beyond the what can be called falsifiability criteria. If we cannot show that these are true, it cannot be even shown that these are false. So how do we tackle such kind of sentences? Then we say, truth functionally or cognitively speaking, these are meaningless expression. That means if any sentence fails the criteria of verifiability, they ceases to be a scientific expression. They are, as far as scientific knowledge or scientific activity is concerned, they are meaningless expression, and we don't want this kind of meaningless expression in the body of science. So we have just seen that logical empiricists introduced a principle of verifiability to distinguish what is a meaningful expression in science and what is not a meaningful expression in science, and thereby they have made a rigorous attempt to eliminate all meaning expressions in the scientific body of knowledge. But this criteria or this verifiability principle underwent a rigorous modification. So now we would really like to see what the principle itself is and in what ways it has underwent rigorous definition and reformulation and modification and so on. The first was given by Slick. His formulation is that a sentence is meaningful insofar as it has the method of verification. Seems to me that it goes well in the sense that if I'm making any observable statement, then it can be easily verified. So the meaningfulness of that expression is correlated with the method. The method is one of finding out verifiability. But Slick, by giving up this kind of criteria, actually faced some kind of objections or difficulties. For example, there are certain statements about history. How can we even verify those historical sentences, like whether Caesar has crossed the Rubicon, that is the Rubicon River, or if you're making any expression or statement about the experience of others, other persons, then how can we verify those experiences? In principle, you cannot. So does it mean that the experiences of others which are described in sentences are meaningless? It's very difficult to say. So the method itself has its own limitation. Moreover, there are some kind of generalized statement. Let us say all bodies attract each other. Such sentences are not verifiable in experience. So Slate himself faces a lot of problem when he came up with the criteria of verifiability. And here is where Ayer, A.J. Ayer comes in. He reformulated this principle of verifiability by coming up with another criteria. So it is not meaning is associated with method, but rather a meaningfulness of an expression is related with a criteria, with a condition which can be satisfied if it is a scientific statement. Ayer says that a sentence is cognitively or factually significant even only if a criteria can be provided to verify the claim. Now once you have this, you can make then you can tackle some of the problems of Slick, because you know a criteria, you know a condition, how a certain historical statement can be made true or false. Even the experiences of others by coming up with certain conditions or criteria can be determined to be true or false. Having encountered this problem, he modified his criteria again. He gave a weak version of the principle or the criteria of verifiability, that in principle it must be deducible. That means an expression should be deducible and that it should be testable. I mean, what do we mean by this? For example, let us take a context that all humans are mortal. That is a generalized expression, and if I can show that Mr. X is a human being, from here I can say that Mr. X is mortal. So the fact that Mr. X is mortal is a meaningful expression comes from the derivability factor. So this is meaningful insofar as it has been deduced from general statements in conjunction with some kind of sentences which are partly observable. So observable statement is involved. For example, that Mr. X is human is observable. So in the light of some observable statement, we can deduce the sentence or derive a sentence which says that therefore Mr. X is mortal. So he tries to tackle this problem by slightly modifying the principle of verifiability, saying that I am not supporting the stronger one but the weaker one. His weaker or modified version of meaningfulness criteria has been challenged by Isaiah Berlin, saying that we can have a situation such that even if observable statements are derivable, certain statement will cease to be meaningless. For example, we add another sentence, the absolute is lazy, therefore this chalk is white. Now this is basically a form of argument called modus ponens, and this as a form of argument this is valid. In other words, the sentence that this is white, it can be verified. it can be verified. This is white, whatever it stands for, verified to be true or false. So that just because some observable statements are derivable in conjunction with certain other statements doesn't make those statements meaningful. For example, the absolute is lazy. From here, with the absolute is lazy and then some other observable sentence, we are deriving this dog is white. But because it is derivable, it doesn't mean that suddenly now the absolute is lazy has become meaningful. So he says that there must be a possibility to check the verifiability directly or indirectly of those sentences. If there is a possibility, then it becomes meaningful. For example, a sentence like the absolute is lazy, there is no way directly or indirectly to verify the claim of this one. So he modified a little more by saying that if there is a possibility, then we can say it is meaningful. So he come up with the idea of the example that I have mentioned before, that all crows are black. This particular thing is a crow and therefore it is black. There is in principle a possibility to show that the crow is black. So that possibility itself suggests that whatever we derive, therefore the crow is black, is meaningful. So the idea that in principle it is verifiable, that there is a possibility that it can be verified, and that is connected with a generalized statement, provides the meaningfulness criteria of a sentence. But there are further problems even after modification, because one brilliant logician and mathematician, Alonzo Church, has come up with a counter example, saying that there are certain things, there are certain logical expression, logical formulas. If you take it, you may be able to derive certain consequence. Rather, let me put it this way. You know that there are certain expressions which are true, which are verifiable, but taking this criteria of derivability in conjunction with certain other sentences, you cannot derive this particular sentence. But you know that in principle this is verifiable. The example need not be given, but the form of the logic is that there may be a compound sentence. Within that, that certain expressions which are observable in nature are not derivable. But if we put some other sentences, it becomes derivable. So the criteria that the meaningfulness of certain expression which is derived from a formula doesn't hold good. The criteria given by Ayer. So this criticism or counter example has been given by Alonzo Church. Now, what we are actually trying to say is this, that the meaning of the criteria of meaningfulness given by Sleek, given by Ayer, all fails the test. In a sense, it is not conclusive. There is no conclusive way or definite way of saying that this is meaningful and this is not. So all attempts so far to block metaphysical statements saying that they are not verifiable fails so far, given by according to the criteria given by the logical positivist so far. Now, in order to respond to challenges, Hempel has come up with the idea of translatability or translatability criterion. What do we mean by this? Is that okay? In formulating scientific sentences or scientific propositions, we use certain terms. If only those terms can be correlated with some observational terms, then we need not come up with criteria or a method of verifiability, criteria of verifiability. But if only those terms which are used in the formulation of scientific sentences, those theoretical terms can be correlated with observational terms, then that scientific expression becomes meaningful. Let us take an example, that weight. What is the weight of this thing? Weight is not observable, no. But there is a mechanism by which we can translate this term into something experiential, practical. So we can quantify it. So we can take different measurement scales and then say the weight of this is this, the weight of this is this. So weight itself as a concept is not given to us in experience, but we have a method, we have a standard by which the weight of a certain thing can be measured. So measurability, and that measurability is actually observable in the sense that we can actually measure the weight of certain things. So if certain expressions, a theoretical expression occurs in a scientific formulation, then we can correlate with observable things. Like another example could be electrons, or there are certain things like mass or force which are not directly given to us in experience. We cannot see it directly, and therefore they remain as theoretical terms. But indirectly there is a way to correlate with experiment or observation. So if we can find that kind of mechanism by which we can translate so-called theoretical terms into observable terms, that is something which we can manipulate, which we can interfere, then it will be taken as scientific terms, and therefore there is a legitimate use of these terms in the formulation of scientific principles and laws. So the idea of translatability has been given by Hempel. In what way this idea of translatability help in solving the problems of logical positivist? It is said, for example, again we are so used to using the example of God. If we say God is tall, or God is perfect, or the absolute is lazy, then there is no corresponding observable fact in the world which can be measured, which can be manipulated. So if something like perfection, something like God, or something like substance, this occurs in a scientific formulation, then we are not able to verify, we are not able to translate them in terms of certain observable situations. So therefore we are able to block that kind of metaphysical categories or metaphysical terms in the formulation of scientific laws and scientific theories. Now in addition to this principle of translation, that is translating theoretical terms into observable terms, Hempel has given a rigorous logical form or logical structure for doing science that he gave in terms of providing a logical language. That means there can be artificial language. We can construct an artificial language, something called logic, and that there is a syntax and a semantics. There are rules for formulating certain expression, and then there are ways of allowing certain expression to be part of that language. So he provided a criteria of that language, language of logic. We can look at that criteria here. The vocabulary of L contains the customary locutions of logic which are used in formation of sentences, including in particular the expression no, which is negation, and conjunction or disjunction, if then, which is implication, and quantifiers like all, some. So these are part of the vocabulary of the language of science. The second is certain observable predicates. By this we mean that the properties which we are ascribing to certain terms are observable. When we say table is brown, brown is observable, or that this motion is fast or slow, those are observable. So when we are ascribing or predicating certain properties on something, the subject, then those are observable. So the criteria is that the vocabularies of this language of logic, should be all those which are logical. Means there is a language of logic, should be supplied from logic, and if there are other terms occurring in that those terms should be observable. The predicate, the properties which we apply on the terms should be observable. The third criteria: any expression definable by means of those preferred by under 1 and 2. Here, if we are introducing a new sentence into the language of scientists, then those terms or languages should be defined, should be given a rigorous definition in the light of sentence 1 and 2. So this is the first part. And the second criteria: the rules of sentence formulation for L are those laid down in some contemporary logical systems such as Principia Mathematica. So how are we to construct such a language? Actually, the Principia Mathematica is a book published by jointly published by Russell and Whitehead. Here they have formulated a language of logic such that if you apply all the rules and the conditions of this logical system, then this logical system provide adequate language for doing science. So the symbol system, the structure of logic, the language of logic is available in this book of Russell and Whitehead, Principia Mathematica. So what he's trying to do is this, that we are going to provide a language for doing science, and that language is of this type. We will only allow terms which are observable, otherwise logical, and the rules for generating new sentences are according to the rules of logic which we find in the let us say first order logic, or which are given to us in the book Principia Mathematica. Now if we rigorously apply this in the scientific activities, then of course we cannot entertain a sentence like the absolute is lazy, because God is not a term, it's not a logical term, it is not even verifiable, it is not even observable. So likewise, if we introduce all these observable and logical terms into the formulation of a language of science, then all metaphysical sentences are abundant, means filtered. They cannot become part of the scientific expression term. But this has some difficulty as well, and then this needs to be reworked, because surface level it seems to be working well, but there are problems, and then there are attempts to modify this one, and we can take a look at this. Let us have a look at the slide. What Hempel is trying to say is this, that there should be a logical or mathematical language or model in order to provide meaningfulness criteria of a scientific expression. And this expression, when expanded or explored further, will have this series of conditions or implications. Let us look at those points. The theory is formulated in a first-order mathematical language with equality. The non-logical terms or constraint of L, that is the language, are divided into three disjoint classes called vocabularies. 1. Or A, the logical vocabulary consisting of logical constants. 2. The observation vocabulary, that is terms which are observable. 3. The theoretical vocabulary, that is represented by VT, that means theoretical terms. The third criteria, the terms in the V0, which are observable terms, are interpreted as referring to directly observable physical objects or directly observable attributes of physical objects. Attributes are like colors and things like that. Fourth, there is a set of theoretical postulates whose only non-logical terms are from theoretical entities or theoretical terms. The terms in VT, which are theoretical terms, are given an explicit definition in terms of observable terms, VO, by correspondence rules. Rules C. That is, for every term there is a function, there must be a given definition for it of the following. So that particular language has been expanded like that. That means any term occurring in the formulation of science, terms which are not observable, but which are theoretical terms, there should be a function such that observable terms or theoretical terms are correlated with observable terms. So the correspondence theory is actually correspondence theory of truth is used in the formulation of this criteria or the language of meaningfulness. Having said this, now we know that there are certain sentences which need not be verified at all, by which we mean analytic sentences. What do we mean by analytic sentences? That means sentences are true or false by virtue of the terms or the grammar which are used in the formulation of that expression. The typical one we know is that triangles are three-sided. We know that this proposition is true. The very definition of triangle says that it has three-sided. So we don't have to look into the world to see whether given any triangle it has three sides. No, by the definition itself we know the sentence is true. Or take another favorite example of philosophers, that all bachelors are unmarried. The idea of bachelor says that these are unmarried men. So what is there in the predicate part of the sentence? Unmarried male or unmarried man is already contained in the word bachelor. So for the truth of this sentence, we don't have to look into the world. Are you a male? Are you married or single? And then whether this expression is true or false. No, we don't have to look at the world in order to determine the truth value of such analytic sentences. So there are certain sentences which are analytic, geometry or any mathematical expression. Those are true analytically. It doesn't depend on the world or facts to justify its truth claim. So though these are not observable, in other words, there is no attempt to translate theoretical entities of mathematics, let us say, into world of observable, and yet these are an exception, analytic proposition. They are true by themselves. However, with exception to these analytic statements, if we are going to allow any other kind of sentences to be included in our scientific language, then it must be empirical. That means it must be observable. So these two, analytic sentences are admissible and observable sentences are admissible. Now if there are any kind of generalization or law-like sentences, then we are saying that all these by law-like sentences we are introducing theoretical terms or concepts which are not given to us directly. So we are able to reduce or correlate this into observable sentences. So this is the idea given by Hempel. However, there are so many even within the logical positivists who are not happy with this criteria, because ultimately there is no exhaustive way to explain all theoretical terms in terms of observable terms. So people like Carnap and Hempel themselves admitted, yes, it is not possible to exclusively or exhaustively show that every term which are theoretical can be translated in terms of observable terms. So there are problems and they have acknowledged that kind of problems. So somebody said that why not use falsibility criteria, testability criteria to say that something is scientific, and to that extent Hempel has welcomed that criteria. By falsification or falsifiability as a criteria is associated with Karl Popper. In this, basically he is trying to demarcate science from pseudosciences. They may be using the method of science like induction, like observation, but at the end of the day it may not be scientific, because the theories which are formulated from generalization of observable things are not falsifiable. They may use, but there is no mechanism by which this theory can be falsified. So Popper says that if a theory is scientific, it must come up with a criteria or a condition which says that under these circumstances this theory will become false. we can imagine that let us say numerology or palmistry is some kind of science, because we look at different hands, we look at different numbers, and then taking into consideration a large number of data, then we make speculation. Any people having this kind of lines on a palm will have this kind of characteristics or trait, or anybody born under this kind of academic year, months of the year will have this kind of behavior. But is there a way to falsify it? If somebody says I am born under this horoscope sign, but well, the horoscope says I'll be this, I'll get married by 30, but I didn't get married, does it mean that my horoscope theory has gone wrong? Within this so-called pseudosciences, there is no way to falsify it. Rather, they will want to modify it again and again. But Popper says that if something is scientific, then there must be a falsifiability criteria. For example, if there is a saying that if anything is a metal, then it expands on heating. Now, if there is something which is said to be metal and yet it is not expanding on heating, that means my claim that all metals expand on heating has been falsified. This is not adequate to make a generalized claim about metals. So falsifiability criteria has been given by Popper. Whether Popper is a positivist or not has been a matter of debate. But the fact is that, or rather the point is that positivists, some of them like Hempel, have accepted this criteria given by Popper in order to make a distinction of science from non-sciences. Now we have seen that different criteria have been forwarded to define the meaningfulness of an expression in science, or the condition that should be satisfied to become a meaningful scientific expression, or the criteria of falsifiability has been brought in to make distinction between scientific statement and non-scientific statement. But in all this, there are a measure of arbitrariness, in that there is no absolute way to say that that this is scientific and this is not scientific because of this criteria. So all the logical positivists who are trying to demarcate science from non-sciences or pseudosciences have to some extent failed, and they've acknowledged that. But just because they have not been able to come up with a very definite criteria, does it mean therefore science is arbitrary? Does it mean that the principle of verifiability that they have given is somehow arbitrary? Here they don't want to say that it is arbitrary. The principle of verifiability itself, that anything to be meaningful must be verifiable. That statement itself is not analytic. It is not given to us in experience. So by the very criteria of meaningfulness of an expression given by logical positivists, the principle of verifiability is neither true nor false, and it becomes a meaningless expression. So these are some of the paradoxical situations they even face. But they say that that verifiability principle which has been given is not part of the object language. It is a meta rule, and not a proposition. So there is a difference between proposition and a rule, and saying this is a rule, and this rule actually help us to distinguish what is a proposition and what is not. So in that way, some of them are even saying that generalized statements, laws of science, are not to be treated as a proposition which are true or false. Rather, those are rules, those are instructions of how we should go about sorting out our sentences or making a certain scientific observation. So laws are not, laws in a sense, generalized sentences are not actually truth propositions, proposition claiming to be true, but those are to be treated more like rules, some kind of guiding principles which will help us to understand the world. So it has no truth value. Some of them responded like this, and even in close connection with that idea, the verifiability principle, which is not analytic, which is not observable, Therefore, according to them, it is a meaningless expression, but they say it is to be treated more like a rule. And this rule helps us to distinguish what is actually consistent and inconsistent within the body of science. So, though there is a measure of arbitrariness in that we cannot absolutely block some metaphysical sentences from entering into science, by introducing this criteria of verifiability, there is much that we can do, in the sense that we can block certain unwanted expression, plus using these we can actually check question of consistency and inconsistency in science. So if there are two competing theories, one is scientific and one is not, by bringing the principle of verifiability, we will show that if we combine these two, it results in contradiction. However, if we allow this principle to work, then we can block this inconsistency, and therefore any scientific theory will become, to some extent, to a great extent, become consistent. So verifiability criteria, though at the end of the day is not able to bring that definite distinction or demarcation, helps in formulating scientific theories in certain way. So that's about this module. So what we have done here is that to end up this module, we have said that philosophy of science in the initial stages of development is articulated by a logical positivist or logical empiricist, and they did this by coming up with the criteria of meaningfulness, and that meaningfulness criteria is called verifiability. The criteria itself has undergone rigorous definition and modification. We have just seen that within the positivist scientists themselves, they have accepted, rejected, modified, and even at the end of the day, they are all saying that yes, we have failed in providing the ultimate criteria. But then they are saying that we have contributed something in the development of philosophy of science, and that their contribution cannot be just brushed aside, because just on the ground that they have not given us a complete or a definite criteria. So to that extent, we can say that though they have failed in their attempt, they have actually contributed a lot to the development of philosophy of science. So even if after the rejection of the criteria, their suggestion is actually useful still in the development of philosophy of science. Thank you.